25 years in this house that my wife and I built ourselves. She was the principal designer. She would design it, and then in the evening when I'd come in, I would critique it, and then she would redesign it. And by the time the excavator arrived, we took the design that she had on the sheet of paper and we went with it. In 1985, we broke ground on this house. It's not finished yet. It's probably 98% finished, but there's some finish work that needs to be done, such as molding around the floor, upstairs, and actually we're at the point where we're redoing some things. Like I'm redoing the bathroom. I'm going to retile the bathroom up there. So it's home ownership involves a continuum. If you build a house, usually you get it done, and then you have about 20 years of maintenance-free, relatively maintenance-free living before you have to replace the roof or whatever. This is basically a salt box design, which is helpful for getting the sun into your house so that you have day lighting. Most of the windows are on the south side. We put a few windows on the north side. Back then it was highly discouraged to do so because of the leak in the north wind and so forth. But for daylighting purposes and for the view, we decided it was worthwhile. And I'm glad we did. One thing I would say about any kind of technology that you're applying to your house, you need to be happy with it. You shouldn't do something in an extreme fashion when a more moderate approach will make the house more livable and more fun for you to be in. So, as the Greek said, everything in moderation, and that's true here. Obviously, we built in the woods. If you wanted the maximum benefits of solar, passive solar, or active solar, you would build out, as our neighbor did, out in the meadow over there and get full sun. We liked the woods, and we wanted to maintain it, and I was very, very judicious about the trees I cut. So why don't we go inside and take a look?
Reese continued the tour of his house by going inside to describe the green technologies that he's utilizing.
The sunlight comes in here, it strikes the slate, it turns from light energy to infrared energy, and it absorbs through the slate into the concrete, and then all night that heat radiates back out. Then a very important feature of the house is the thermodynamics, the airflow. We use the fan occasionally. Haven't used it as much as we thought we would because we're in the woods and it stays pretty cool. So one of the most important solar features is that at the end of April the leaves come out and the house is then shaded through, or most of the house is shaded throughout the summer. So consequently there's very little need for air conditioning. Here's our principal source of heat, wood stove. The wood is of course native, easily available. Wood is a very cheap source of heating a house. Of course it's traditional, it's been used for centuries. Using an airtight stove makes it a lot more efficient. You know, of course solar is actually free, but you have to build a system that can capture it. And if you're going to make any kind of investment in solar, the most efficient payback, or the quickest payback, is to install a domestic solar hot water system. The payback on that, the last I heard, was about 3 years.
Reese's solar panel system is a short distance from his house.
What we have here are 18 panels. They're Sharps, 224 watts each, and that's the label capacity. No solar system that I know of operates at the label. It's what's called derated, and the derating is usually about 15 or 18%. The best days are cool, clear days.
And with those you can get, well, I've averaged with this system, which is just over 4 kilowatts, I've averaged 380 kilowatt hours a month for the past 2 years that the system's been in operation. And it hadn't been in operation quite 2 years. I had to project the last couple months. But what I'm having to buy from Appalachian Power is about 200 kilowatt hours a month. So I'm consuming roughly 580 kilowatt hours a month. Of course, I'm generating a lot more in the spring and in the fall. The way the system works with American Electric Power, this is a grid-tied system, so that when I'm generating more power than I can use, it essentially turns the meter back and I feed the power into American Electric Power through the Appalachian Power Company. Then when at nighttime or when the sun goes behind a pretty dark cloud and the generation drops, then I start drawing off of American Electric Power. And so the power company will actually buy this power at somewhere around 11 or 12 cents per kilowatt hour. One of the things you have to watch when you're situating your solar array, most people will just stick it right on the roof, which works great if you've got a good orientation for your house. I did not. Well, the house would have been all right, but with the woods, it wouldn't have worked. This whole array in a turnkey fashion cost about $27,000, not something a student is going to buy. But there were incentives. First of all, the American Recovery Act was encouraging renewable energy. It wasn't a do-it-yourself project. I could not get a rebate from the Recovery Act if I bought and installed these myself. They had to be installed by a certified electrician. And so it helped to stimulate the economy, helped to stimulate renewable energy as a business. One of the problems with solar is there's a lot of labor involved. Now I did order a kind of Cadillac rack because I'm not on the roof, so I can move these panels up and down according to the season.
Raising and lowering the panels can be a tedious process, but Reese walked us through it from beginning to end.
My wife came up with the idea of putting this gutter, suspending it so that the water, when it rains, falling off of the top row of panels would fall into the gutter and run to the rain barrel there. Insulation is by far your best investment after weather stripping. So think about how you might be able to just make your house tighter, how you can operate water in a way so that it's more efficient. You might be able to turn the thermostat down, both on your water heater or in your space where you're living, on a wall thermostat, so that it doesn't really make it uncomfortable for you. It's just cooler at night. You pull up some blankets and it's real cozy. So make use of the equipment that is available to help you control costs and control your emissions. And maybe at some point you can invest in photovoltaics. And that is going to be more and more feasible for you guys because they're producing products now like shingles for your roof that are each solar cells.
Next, we go to Jack Mason's house, outside of Meadowview, Virginia.
I had a father who was a tinkerer. He was always building things out of nothing. Dad was one of those people that made things work. And so I guess I inherited a little of that spirit. I didn't really get started in solar seriously until 1977 when I worked at Miami University. And there at Miami University, I started Miami University in Ohio, My wife is reminding me quietly. There's where I started my thinking in solar and really wanting to do it. I had students that worked for the university, so I had my own students, and I required them to do a solar project after I really got to reading and thinking about it. And then I realized I'm having them do a project, I should do one. So we converted our home into passive solar home by adding a lean-to and plastic sheeting, and we were in a pretty fancy neighborhood, and we thought the neighbors would kick us out, but they all come and cheered us on. So that particular winter was a minus 36 degrees in our yard, so it was appreciated to have the solar. So that's kind of where I started.
Jack monitors his water and electricity carefully.
This box, of course, is a controller. This is the controller here, the differential controller. Inside there are pumps that actually do the pumping of the water. Then there's a second sensor that's very important that goes down and goes inside here to the bottom of the storage tank. These temperatures are taken at the outside surface, so they're a little bit hotter inside, but that temperature right now is like 116 degrees at the bottom. So we have water ranging from 116 to 120 some degrees in that 80 gallons of water. There are two pumps here. This pump, and they both come on at the same time, but this pump pumps the water up through those pipes up to the collector, back down through the drain back tank, and inside the tank. Now, as it does that, it has to go through here and pass through a heat exchanger that's underneath this black foam. It goes through that heat exchanger in that circular exchange there. At the same time, this pump comes on and pumps water out of the tank, out of the tank this way, down through, and goes down through the heat exchanger and back up and back into the tank. So that's called a solar thermal system, and it's basically heating the domestic hot water for the house. It will get very hot. We can set it to max out wherever we want it. Some people set it at 660, some 150. So this little device over here is a tempering valve, sometimes called a mixing valve. And what it does is when the hot water is going to the house, it mixes some cold water with it. And you can turn this knob and set it wherever you want it.
Jack then takes us outside to see the solar panels.
We refer to this as a solar electric system, and it's actually photovoltaic. And the photovoltaic is a system which depends on silicon solar cells. So this house has two arrays on it. On the left there, you'd be with where the chimney is, there's an array of 14 230 volt photovoltaic modules. On the right is also 14 photovoltaic modules, each is 230 watts. Now you notice that they're at different angles. The flatter they are, the more wattage they produce, the more solar electric they produce in the summertime. But the tilted ones do a little bit better in the winter, so we just went ahead and did it so that we actually had a little of each. If you look back, you'll see two gray boxes. Each array goes through that box. That could be just a little junction box, and we could have hit it. But I decided that if I was up on the roof and I wanted to shut the system down, I didn't have to go all the way down, off, and into the basement to do it. So instead of having just a hidden junction box, I put mine out where they can be seen. And so as quick as that DC current comes out of those solar cells, out of those modules, it goes and immediately is converted into AC current. And so it goes all the way down through the attic and down through into the house breaker panel as AC current, which is exactly the same as the power company's producing. So the two match and just works beautifully. And this means we have an on-the-grid system. We're hooked into the grid, and it's also referred to as net metering because it will net the amount of energy that's actually used by us. modules put out a total, or are rated at a total of 4,440 watts. That's DC. By the time that's converted to AC, it's going to be just about 95% of that. So we'll show you the metering system, and we'll show you by the computer system inside the house more about how it works.
Jack takes us inside to the computer system, where his wife Diane shows us how it works.
Several things that you can do with this system, and the main thing that we do, and we don't check it often, you can check the modules up on the roof, and this is how they're set up. If you recall, the one roof had the modules here, and then this other roof had them set up like this. And right now it's showing how much energy that we're getting. The other thing you can do with this is you can check to see if they're working all right. As long as they look like this, everything's fine. If there was some problem, they would light up. They are very durable, and we had the hailstorm that damaged our roof, but the part of the roof where the solar modules wasn't damaged at all, and the modules were not damaged. You can also see, this is a little graph of the amount of sunshine that we've gotten. Actually, that's not today. This is today, and you can see the lines up and down. On a really nice sunny day, it'll look like this. And you can even determine what time of day this went.
Jack then takes us below his house, where he shows us how he distributes rainwater throughout his home.
This is what we'll call the rainwater harvesting system, and what I did was pump the water with this pump. I'm pumping the water through this line here. That's coming from the cistern. Goes in, and this is a pressure tank, so we'll have pressure to feed the water through these two lines here. It comes up through here and feeds out through these two lines and goes to one bathroom upstairs and another bathroom in the lower level of the house. That for some reason I couldn't use the cistern anymore, then I can simply close this valve, open this valve, and the water then from the county system will flow through this check valve and in and over to the toilet. So I can run it either way, and the reason for the check valve is so that never any water can backfeed and go into the county water system.
These are a couple systems that Jack has developed for third world countries.
The advantage of the flaps is that they are reflectorized, and so the sun hitting those big lids there that I have tilted back bounces more light inside the box. This box has copper tubes in it here, painted black, and it's called flat plate because on the bottom you always put some metal. Copper would be ideal, but we can't afford copper usually, so we put aluminum flashing in there, just a thin aluminum, and screw it down to the bottom and paint it black. These two pipes right here, we fill this with water. The water's going to go down, enter the bottom, and come up through the copper tubes and fill back up to the top. That'll all be full of water when we fill it up, and then when the sun starts shining on this glass, shortwave energy, light energy, will go through that glass very easily and down in and heat the water in the copper tube.
Now we go to John Towers, a homeowner in Damascus, Virginia, who has a different approach to sustainable living.
We're not going for high tech, we're not going for perfection, we're just trying to make it easier to save energy, to keep, in the winter, keep the heat in the summer to keep the heat out, as inexpensively as possible. This is a brick ranch house. It's about 1,200 square feet. The lot is about 1.5 acres, and our thought was to begin to do alternative living lifestyles in such a way that people could actually see what we were doing. So we put in rainwater catchments. So we had, I put in a 1,700 gallon cistern, and that was sitting out there. People would stop and wonder what that was. We dry our clothes out outside, which not very common nowadays. increasing insulation, making window quilts, just affordable changes, little by little, so that we could just easily demonstrate for ourselves and for others that it was really possible to live with a much smaller energy footprint. We started, a typical household in this country is about 1,000 kilowatt hours a month. And little by little, by just making, at first, very small changes and paying attention to very small uses of energy, we were able to, last month, which was our, basically our January, February bill, in the middle of winter, we used 100 and I think it was 84 kilowatt hours, as opposed to over 1,000. So, and we continue to live a pretty standard lifestyle. We started out with electric bills of about $100 and something a month, maybe a little less during the summer. My electric bill was $29. I'm on a $39 budget, but the actual use of electricity was $29, which was about 184, I think, kilowatt hours. The insulation in this, there was an R11 overhead, which isn't much. The code now requires an R38 for insulation overhead. So I realized, because the house was very hot in the summer and it was cool in the winter, and the house had central air conditioning and it had a central heating system at the time, that the first thing I really wanted to do was to increase insulation. So overhead for the entire house, we put in a minimum of 12 inches of cellulose fiber insulation. Now what that did is, cellulose fiber is a great fireproof insulating material. It's recycled newspapers, basically. It gives you a very high R value. So for $750, that's what that cost me. I was able to eliminate AC, the air conditioning, central air. We simply didn't need to use it anymore. The laundry, we have an American-made washing machine. It's called a Staber. Instead of using 40 gallons of water per full cycle, which is what a normal top loader would use, it uses 13 gallons of water. It also uses very little electricity, so when those clothes come out, we can put them out on the clothesline, and in 1 hour they're usually dry. This was made in Canada. It happens to be a very efficient, beautifully made cook stove. During the heating season, which is about 6 months, we do all of our cooking, baking. We bake bread every day or so. It also provides all of our hot water. So in this case, there's a water jacket in the firebox which circulates water to this 80-gallon, what they call a range boiler. And this range boiler is just hooked into the regular plumbing in the house. So as long as that fire is going, it is continually heating water for the rest of the house. 80 gallons is a lot of hot water, so we have had no trouble with 4 or 5 people in the house taking showers, doing dishes, whatever it might be, cleanup. And then behind the stove, which you may not be able to see here, is another 20-gallon tank, which is not pressurized. There's a tap here that we can open to get water, and that's hot water. And we'll use that for laundry or for anything else that we need hot water for. And then, of course, in addition to that, this stove heats the entire house. So I think a lot of people wonder, well, how can you do this? This stove is way on this side of the house. How does it heat the rest of the house? Well, what I've done is to open up the transom spaces above the doors. So all of the heat, the hottest part of the hottest air rises to the ceiling. With these open, that hot air simply shoots to the back of the house, forcing cooler air to come in, drop to this floor to get reheated. Nothing mechanical, no fans or anything else, just the natural convective movement of the air the house becomes comfortable. These are just some of my manual toys. I, constantly trying to find different ways to do things without using electricity. So we've got an ice cream maker, a butter churn, meat slicer, cabbage slicer. This is a food processor, manual food processor, which works beautifully. I've got a potato cutter, a couple grinders, another butter churn, and this is basically an espresso cappuccino maker. Lights in the house are compact fluorescents. These actually happen to be LEDs. I decided to try LEDs. They all have their downside. There's toxin issues, but everything's a compromise. You find that you can't. There is no perfection. So you have to weigh the benefits and the disadvantages and just make your own decisions.
Well, you have to start with where you are. You have to start with what your choices are going to be in terms of how you're going to live. You have to choose where you're going to live, because you're probably, certainly as a young person, the biggest contribution to your carbon footprint is your automobile use. I mean, that's something almost anybody can do. Talk to their landlord, think about where they're living, think about the car that they're about to buy, and you may be able, even in a rental house, to operate with a wood stove. You have to be safe and learn about it first, but you can do that.
What's happening right now, the state of solar electric, there are markets now that we have reached parity, which means it is cheaper to put solar on your roof than it is to buy your energy from the grid. In Maine, there's an article out that Maine is now, it's 15% cheaper to use solar. In New York City, it is now 60%.
It's kind of being conscious about everything and trying to figure out a way not to have to plug something in. And it's a challenge, and it's fun. I mean, it's a fun challenge to constantly trying to chip away at that the kilowatt hours. I mean, it's and that's what I suggest everybody do. Just when you're starting out, just start from where you are and say, well, how can I reduce this next month? How can I reduce this next month? And just keep doing it. And the same with waste. The same with your purchases. I mean, it's just about and trying not to sacrifice your lifestyle in the process. Still need to have fun.
Yeah.